Hi, I'm Pat. Okay, in this problem, this is what they've given to us, what they're even describing in the directions as a reduction formula. And our job is going to be to verify that reduction formula. And the instructions are also telling us to further verify that with some graphing utility. Okay, so a graphing calculator or some kind of software we're going to end up getting to at the end, but that will just further confirm what we're already going to show with some paper and pencil work. Okay. All right, and that work that we're about to do then is kind of like the problems I know you've been doing with verify the identities, because that's what's going on here, is we're calling it a reduction formula, but it's an identity in the sense that the left-hand side is going to end up equaling the right-hand side, but we've got to show that that's true, okay? And the way that we do these verifying identity type problems is by using some either trigonometry knowledge that we have and or some algebra knowledge that we have. And I've already written a couple of things from trigonometry that I think we are going to use. And everything that I've written over there should be something that you agree with, right? Some reciprocal identities. And then this is one of our newer guys here is the sum addition identity for sine. Okay. So now I'm going to try to manipulate the left-hand side, I'll focus on, of this equation. And if I manipulate it using my trig and algebra knowledge, I'll see if I can end up getting to the right-hand side. And that would be a verification of the formula. Are you ready? Okay, the first thing I do see is a cosecant of something. And I have an identity, a reciprocal identity, that tells me I can rewrite that as 1 over the sine of the same argument, 3 pi over 2 plus theta. Okay, now that's just the left-hand side. And then equals, which we know is true. We know it equals, but we're questioning that. I like to put a question mark. I've got to confirm that this is true. Does this truly equal a negative secant of theta? And then I continue to try to manipulate this left-hand side. And the next thing I would do is recognize that there is addition of two terms inside the sine. So I can use this identity, the sum identity for sine. So 1 over, and now this sine of, think of this as u plus v, and I'm going to follow that formula then, is that it's sine of u, which is the first term, 3 pi over 2, times cosine of v, which is the second term in the argument, which is the theta, okay, plus, and make sure you're keeping lined up with our identity over here. I'm just like right there. Next thing I see is cosine of u, so cosine, and u was the first term inside the argument, so 3 pi over 2, and then multiply by sine of v, and my v was that theta, the second term inside. It's theta. All of this is in the denominator of this fraction, and all of that is on the left-hand side of the equal sign, so I'll carry this down now, and even still question whether that equals negative secant of theta. Okay? All right, now, look more closely at some of these pieces of the puzzle. You have some specific trig functions, or I should say trig functions at some specific angles. And you know what those trig functions evaluate to at those angles, right? Sine of 3 pi over 2. You know that that is a negative 1. Sine of 3 pi over 2 is a negative 1. Cosine of theta, I can't do anything about that. That's cosine of theta. Cosine of 3 pi over 2, though, there's a specific angle, and I know that cosine of 3 pi over 2 is 0. Okay, and then sine of theta is just sine of theta. So let's go down a step here and just clean up a little bit, where I do have this minus I can now use, and even better than that, this 0 that I can now use. So I've got 1 over minus cosine of theta from the first term in the denominator. But then that 0 blanks out the second term in the denominator, so that's it for my fraction. 1 over negative cosine of theta. Does that equal negative secant of theta? The last thing I'll do then is 1 over cosine of theta is one of our reciprocal identities. I did end up writing up there. 1 over cosine of x is secant of x. So for us, that's negative secant of theta. Does that equal negative secant of theta? No more question mark. We know that's true for sure. Okay? All right, good. So we've confirmed or verified this identity, or what we're calling a reduction formula in this problem. But the directions are also asking us to further verify that with a graphing utility. Okay, so let me come over here, and I'll just even do it on a graphing calculator or any kind of computer software, whatever you're most comfortable with. But to confirm this graphically, what we do is back to the original, is we look at the one side of the equal sign as a function, call it like y sub 1. So I'm going to write y sub 1 equals, and I'm just going to write exactly that original left-hand side, cosecant 3 pi over 2 plus theta. And leave a blank for a second. And then the right-hand side, you just want to treat as a second separate function. Okay? So I'll say y sub 2 equals minus secant of theta. And I want to graph each of those. And the reason I left a blank is it depends on the capabilities of your calculator, your software, or whatever. If you don't have like a cosecant key, then don't forget that cosecant is actually just 1 over sine. So my y sub 1, I think I'm actually going to write it as 1 over sine, parentheses, 3 pi over 2 plus, and again, it depends on your calculator or your software if you're going to say x or theta, just whatever your variable is. Since I'm going to my graphing calculator, I'm going to say x. Okay, and my y sub 2, I have to do the same kind of substitution because I don't have a secant key on my calculator, but secant is 1 over cosine. This is minus 1 over cosine of x. And now I'm putting these two functions into my calculator, graphing utility, software, or whatever you're using. I've got mine ready to go. And then when I go to graph it, you should see one curve. And as your calculator or computer is rendering the second curve, it looks like nothing else or nothing new is happening, and that's the point. The second graph is lying perfectly on top of the first graph. Okay? And that's my verification. That's us verifying that identity further using some graphical utility. Okay? Hope that helps. Of course, I hope you try some on your own.